Hi everyone and welcome back. So in this video we are going to be taking a look at unions, and a union is just another user-defined data type, and to understand why unions are helpful and what they allow us to do, let's just do a program. And in this program what we want to do is we need to take a character from the user, and if the user enters I for integer, then we read an integer from the user, and if it's anything else we read a float. And in case of an integer we need to return that integer plus 1, and in case of a float we want to return the float plus 0.1. So once again the program is take an integer, print integer plus 1, take a float and print float plus 0.1. And this is probably how you'd go about writing that program. So I have a char c which will take the I or f or whatever character the user enters, and then I have an int I and float f. And what I do is I do if c equals getChar, so this thing is going to wait for a character input. If that is I, then read the integer and print integer plus 1. And if it's a float, then read the float and print the float plus 0.1. So let's try running this program, and I do unions and then I enter 12, it gives me 13, and this time I enter F, I enter 12, it gives me 12.1. So this is working perfectly fine. But let's take a look here. How many bytes am I using? This is a character, that's 1 byte of memory that I'm using. An integer is 4 bytes, and a float is another 4 bytes. But what I want you to take note of here is that in one run of my program, I'm just going to be using either the integer or the float. So I don't really need both of these in the same program. Of course, one way might be to just move this declaration inside of the if statement. That'll take care of using less space. But what unions allow me to do is exactly this. I can do something like union data, and then I just write int I and float f. So it's kind of similar to how we were doing enums, but what we want to do now is we are saying that I'm going to be using either this or this at a time. I'm not, it might so happen that I use both of them in the same program, but not at the same time. So at one instance of time, I'm either using this declaration or this one, and I could enter as many as I want here. And what I'm saying is I'm just going to be using one of them at a time. So this time what I can do is I can get rid of this, and then I can create a data D. And just like we did with our enums, I need to write union here. So I write union data D, and then I just need to do something like d dot I. And what this d dot I means is that I want the integer part corresponding to a data variable d. And if I wanted more data variables, I could also do d1, d2 and so on, and then just do d1 dot I or d2 dot I. So we don't actually need that here, so let's just stick to d. And here as well I do d dot I, and here I do d dot f and d dot f here as well. And let's try this program now. And once again I do I and then I enter 13, it gives me 14, so that's working fine. And I enter F and I enter 13.5, it gives me 13.6. So this is working perfectly fine. And let's get rid of this part for now, and we can get rid of this as well. What I want to know now is how much space this D takes, and my guess would be that this is 4 bytes and this is 4 bytes as well, so this must again be taking 8 bytes in total. So let's just try that now. %d size of and d, and let's try it out. And as you can see, I got an output of 4. So the space that this D takes is just 4 bytes and not 8 bytes, which is what I would have predicted if this was normal. This was just normally adding these things. But what it's actually doing is it's saying that I'll just have 4 bytes, and those 4 bytes can be used either as an integer or as a float. That you can decide anytime in your program. And what I can also do is I can just write something like char str and 20 here, and this would be 20 bytes. And this time what I'm saying is that I'll either be using an integer or a float or a string of 20 characters, and only one of these will be used at any time. And this time what it does is, let's just check the size once. So I go here and I try this out. So as you can see, it gives me a size of 20. So what it says is that for all of these, what's the biggest data type that I have? That's this string of 20 characters. So what it says is I'll just reserve 20 bytes in memory for this D right here, and depending on which one of them you use, I'll just use either 4 bytes or all the 20 bytes. So if I use this integer I part here, it just uses 4 bytes out of those 20 bytes. And if I use the float, once again it'll use 4 bytes out of those 20 bytes. And only if I'm using the string right here, it'll use all those 20 bytes. So that's how it does it internally. It just gives you space for whichever one is the largest of all of them. And that's basically what unions allow us to do. And another thing that I want to point out here is you can also just make D here. Let me just write D here, and now I can get rid of this as well. And let's try it out whether this gives me an error. No, it doesn't. So basically what I'm saying is just make a variable, a D of this data type right here, and I can in fact even get rid of this. Let's try that. As you can see, it didn't give me an error at all. So what I'm saying is I don't need a name for it, because D is the only variable that I'm going to create of this type right here. Whatever type this is, we haven't given any name for the type. And D is the only variable that I need of this type, so I'll just mention that here. So that's another thing that I can do. And I can also just give all of my D1, D2 right here, or I can just make a type of data and then create it here like I was doing earlier. So that's about unions. And one last thing I want to point out before I finish off this video is, if you try to assign, let's say you try to do something like d.i equals 5, and then you try to access d.f. So let's say you do something like print d.f. That will give you some unexpected behavior. It might give you some random value. So just stay aware of mistakes like those. And that's basically it about unions. And one thing I want you to think about before the next video is whether we can make a complex data type for complex numbers using this union right here. So basically, can I do something like union complex and then write something like float real and float imaginary? I want you to think about whether doing this is possible and feasible, and we'll take a look at complex numbers in the next video. So I'll see you there.